Welcome. Today we're going to talk about squares. Now you might think you know what a square is, and you probably can recognize one. But really a square is just a rectangle that is also a rhombus. So here's a rectangle. You recognize a rectangle by its four 90-degree angles. But if you shrink it so that all four sides are congruent, making it a rhombus also, then it's a square. So what this means is that squares have properties of parallelograms. Opposite sides are parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and the diagonals bisect each other. But it also has the properties of rectangles. So all of the angles are congruent and the diagonals are congruent. But then it also has the properties of rhombi. So all the sides are congruent, the diagonals bisect the interior angles, and the diagonals are perpendicular to each other. So to summarize this, all of your sides are congruent, all of your angles are congruent, and your diagonals not only are congruent, but also bisect each other, bisect the interior angles, and are perpendicular to each other. So let's see what we can do with this square. We have three things we're going to try to find. These are all separate things that we'll calculate separately. The first one I want to find is the measure of angle ADB. Now that's an angle in the corner. Notice it's from an edge to the diagonal. So the thing to remember here is that that main corner there at D is a 90-degree angle. Angle ADC is 90 degrees. But since it's a square, the diagonal will bisect that angle. So we'll divide that in half to find the measure of angle ADB. So we're looking at a 45-degree angle there. BC is probably the easiest one for you because you are fairly familiar with squares and you know all the sides are congruent. So if the bottom side's 13, so is the right-hand side. BD is the diagonal. We do have enough information to find out how long that diagonal actually is. But again, you have to remember that we have right angles. So when the diagonal cuts the square into two triangles, they are right triangles. And if it's a right triangle, we can use Pythagorean theorem. Now the a squared plus b squared equals c squared. A is a leg of the right triangle. B is a leg of the right triangle, which basically means sides of our square. So we'll have 13 squared plus 13 squared. And then our diagonal, that becomes c. As we start calculating this, 13 squared is 169, so we can substitute that in. We'll go ahead and add to get 338 equals c squared. Then we have to do the square root of both sides. That's the step that everyone forgets because we don't want c squared. We want regular old c. Then you use your calculator and you find out that c is approximately 18.38. And that's really every problem that you have to do with squares is going to have something to do with the angles being 45 degrees, the sides being equal, or the fact that the square can get cut into lots of different right triangles. So to summarize with squares, all your sides are congruent, all of your angles are congruent, your diagonals are congruent, they bisect each other, the diagonals bisect the interior angles, and the diagonals are perpendicular to each other. So it's all of those properties of the rhombus and the rectangle and the parallelogram all put together in that perfect storm for a square. Thank you for joining me for this short talk on squares, and I'll see you next time.